And welcome back. My next guest is Mark Borowitz from DYMAX Corporation. Welcome, Mark.
Good morning. How's it going?
Yes, absolutely.
Pleasure to be here.
It's going really well. This is obviously the last day of the show. But we're here to talk today about the wearables market. Wearables market continues to grow with a wider range of devices that we're all wearing on our bodies, from Fitbits to glasses or other devices to monitor our health, etc. But the big problem with that, of course, is making sure that we're using safe materials.
Correct.
So you've got a range of safe bonding materials that you've introduced to the market. Do you want to talk to us a bit about it?
No, sure. So DYMAX has been a pioneer in the light curable materials. So we're talking materials that cure with high intensity UV light. So to piggyback on that is have materials that are safe for the ever more stringent requirements that our customers have for being safe for really devices that could be on the user 24/7, right? So it's eliminating known sensitizers and using those formulation techniques that still give us the benefits of UV chemistry, but are also sensitizer-free.
Right. Which I know there's a long list of things you have to avoid, but which are the main ones that you're trying to avoid?
It's a good point. So IBOA is the one that everybody's familiar with. I think in 2020 it was literally the sensitizer of the year. But there's also some other ones that we intentionally avoid that are common ones that work fine for other applications, but for this one we totally avoid it.
Right. Okay. And so the applications, you use them both inside the devices and sometimes on the actual bodies of the devices that are having contact with the skin.
So correctly, I mean, we're thinking, as you mentioned, like your fitness trackers, your smartwatches, smart glasses, AR, VR type solutions. So DYMAX has bonding solutions for stuff at the PCB level, right? When we're talking about encapsulants, we have a conformal coating now, some things for ruggedizing and strain relief, we have those. And then also the structural bonders, right? When we talk about, literally putting the device together, buying the different plastics and metals, buying the different lenses and the alignment solutions too. But all those go into the different smart devices.
Really? Okay. Interesting. Let me think. Is this new? Is this a new product you've just brought out, or is this one that you've had?
So it's using existing technology, but using formulation techniques to make sure that we're meeting those stringent requirements too. So when people look at UV technology, right, is that they want the need for speed. Right, and we will produce the most devices as fast as possible.
Right.
So when we compare ourselves to other chemistries that take, say minutes or hours or longer to cure, we're seconds, for it. The other thing with a lot of this series of materials is that they have your UV to activate it, but also a secondary moisture cure function of it. There's some aspects of the bond geometry that maybe we just can't get the UV light to, and a lot of these have a secondary moisture cure to take care of that, to make sure the bond completes its whole cure cycle.
I see. But when you're doing the UV curing, I mean, it's got to be done at a certain particular wavelength to really make it activate quickly.
Yeah, and a lot of these, are not just high intensity UV light. We've formulated these to be what we would consider LED optimized, right? That we can use a specific LED wavelength to give our manufacturers the benefit of using LED curing versus a traditional broad spectrum system.
Right.
I think on top of that, one of the other common questions we get is like, well, how do I detect how to make sure it's on the bond line? So these have also a fluorescing tracer in them, right? So that you hit it with like a black light or low intensity 365 nanometer, I can do my inspection and make sure that the adhesive is exactly where I want it.
Right, exactly. Great. Well, it sounds like a great product, Mark, and I want to congratulations on it, and thank you for coming in and telling us about it today.
No, thank you so much. Appreciate the opportunity.
Okay.
Thank you.
That's great. So don't go away. We've got much more coming after the break.